All right, so let's get started with Kubernetes. All right, so we come with Docker and Docker Swarm. Docker Swarm concepts, we are going to use it. Kubernetes is another orchestration engine. All right, so it's again a container management engine. So let's get started with Kubernetes. All right, you already know me, so I'll skip this slide. All right, now Kubernetes. So if you see here, Kubernetes is also called as K8s, right? In short, we just say K8s. We also call K8s, right? So most of the time when we Google anything related to Kubernetes, right, who will type this big word, keywords, right? Sometimes you make typo error, you will get something else, right? Not the accurate information related to Kubernetes. So we come with a nickname, right? Short name of Kubernetes, which we call K8s. And how this name has evolved, right? Basically what happens, there is a first and last letter, right? First letter is K, last letter is S. And in between, there are 8 letters. So let me count it for you. So Kubernetes, right? So this is the first letter because first letter is already there. So the second letter onwards will be my first letter. So 1, 2, 3, 4, 5, 6, 7, 8. All right, and the last letter S, right? So that is how we come with this name. If I go and type this K8s in Google, Google also knows that this is related to Kubernetes, right? So it is something kind of alias name or a nickname, right? Or a short name which we have given to Kubernetes, right? And it eases our life, right? Instead of typing a big keywords all the time, right? We can just say K8s, right? So this is the short form of Kubernetes. Many a times even you see people refer K8s as Kubernetes, right? So this is our Kubernetes thing, right? So that is how we come to Kubernetes. Now, how do you define Kubernetes? So Kubernetes basically what we know. First of all, Kubernetes we cannot create containers, right? So we need Docker, right? Kubernetes cannot create containers, right? It can manage containers, but it needs Docker to create the containers. And once the Docker will create containers, Kubernetes will take over from there. It says, okay, now container is up and running. Let me go and manage it, right? So Kubernetes is basically a container management tool. So here we need Docker. So Kubernetes is dependent on Docker or any container engine, right? There are many tools in market which are available, right? Docker, Frecti, Cryo, many are there, right? Traffic, so many are there, but out of which Docker is one of the most popular. So it's a container and, right? Plus means and orchestration. So it needs Docker to create container. Once the container is created, we can say it's an orchestration. Orchestration means something to manage. All right, that is what we say orchestration, right? So it comes with its own management layer, and that management layer, what it will do? It will manage container. So if I ask you a question, what is simple? Creation of container is simple or managing container is simple? Or other way, vice versa. What is difficult? Creation of content is difficult or managing the content is difficult? What is difficult? Any guesses?
Managing.
Managing is really difficult, right? Create, I can create in 2 minutes, right? Less than a minute, I can create it. I have to just go and start the content, that's it. But to keep that content alive for 24/7, 365 days, that's really a challenging thing, right? So orchestration is slightly difficult thing, right? And who is going to handle that difficult part? Kubernetes. All right, so we'll create the container, but we need, right, our containers to be always up 24/7, 365 days. And who will help? Kubernetes will help, right? For example, let me give you one example to understand the power of orchestration, right? All the challenges of orchestration. Let's say middle of night when my application which is running inside the container is crashed, right? And middle of night, nobody is there, right? We go home, right? After 6, 7 p.m. at the max, right? 9 p.m. everybody leaves for home and we go home and we eat and we sleep, right? And we are preparing for the next day to come back to the office so that we can start our work. All right. Now, middle of night, some container got crashed and they were stopped. What will happen? In traditional methodology, if I look at it, until and unless next day morning when I go to office, right, and when I walk down to my data center, because that's my job, right, I'm IT support guy or a production support guy, right, I go to data center, look at my production server, and then find that, okay, few applications are crashed. So what we do, right, we'll just go and dig out the information. We need details, right? So what we do, we start with troubleshooting with log files, right? We start, right, looking at the logs, right, and we see, okay, something was not there, resources or something happened, the application got crashed, right, and then what we do, we try to repair, right? We try to repair, try to heal it, right? And once I fix the issue, right, whatever was there, and then again, let's say I reached office at 9 o'clock, that is my reporting time at office. So 9 o'clock I reached, and around 10 o'clock, because I look at the log files, I troubleshoot, and it took time. right? And then by 10 o'clock, my application is up and running, right? And this application got crashed around 1 a.m., right? 1 a.m. in the early morning, it got crashed, right? Middle of the night, it got crashed, right? But when it is up and running, 10 a.m., right? That means 1 to 10, that means almost 9 hours productivity is gone, all right? And another thing is, it is dependent on whom? It is dependent on you, me, right? Human beings, all right? So what happens is this orchestration, right? These guys, they don't wait. What they do, let's say I am running 3 containers, right? So this guy will come to know, okay, 3 containers should always run no matter what, right? So that is the state of my cluster, right? That is my current state, that I should always run 3 applications, right? So this guy will take the status as that 3 applications should run all the time, 24/7, 365 days, right? And how we give all this specification of container to start, right? We give through YAML files. So that means Kubernetes is already having my details of my application. So what it will do, in the middle of night when application is crashed, this guy will come to know, okay, I was running 3 containers, now one is out. That means only 2 is running. That means it says my state is changed. I was supposed to run 3 containers all the time, 24/7, but now I'm running only 2. So this guy will always look at its current state, that my state is changed. What it will do, it will just go and look at the log, the YAML file, which we already have, and automatically just go and recreate the new container. It will deploy the application again right from the scratch. It will not go and look at the log and repair. No, it will just go and recreate the application and it will start again. So within few seconds, right, again 3 containers will be running. So that means this guy will not wait until next day morning when I go to office, look at it, and then I have to fix it. Then only it will come back. No, it already have my YAML file. All the details are mentioned. It will just go and recreate this container, and within few seconds, the moment it come to know, right, within few seconds it will be up and running. So that means that 1 a.m. the application was not there, but 1.1, right, that means 1 a.m. and 1 minute my application is again back up and running, right? So it will not even, nobody knows, okay, what has happened, and this guy will take over. It will automatically create it. So that is the power of orchestration, right? It doesn't need you, me, or anyone, right? It will manage on its own, right? That is what we say, self-managed thing, right? It will manage on itself, right? So that is how Kubernetes comes with that much power, right? I'll give you one more example. Let's say we are running 3 applications, right? And then this guy orchestration continuously do monitoring, right? They come with a inbuilt monitoring layer, right? And that is the power of Kubernetes. So when more and more traffic is coming, right? And then the first container already, right, 80%, right? It's already reached to 80%, right? Then it should not take more requests, right? 90, 95, 96, 97, 98, 99, 100 and blow off, right? And then application is not available because it's already gone down, right? No resources available. It consumed all the 100% resources, and now it is not able to serve any request, right? And it will go down, right? So it, not to occur that situation. So this guy will only send traffic once it reaches CPU and memory to 80%, right? That is my threshold. Then what will happen? It will send traffic to second also, right? It start 20, 30, 40, and yeah, my
Mhm.
audio 80%. Yeah, go ahead, please.
Yes, sorry. I only see the presentation saying container plus orchestration.
Hmm.
Are you still on that page or?
Yes, yeah, I'm there only. Can you see my mouse
Oh,
scrolling
okay.
over as a laser point?
Yes, yes. Okay.
Yeah,
Okay.
so
Sorry.
I'm here
Thought
only.
I thought like you moved on to the next one. Okay.
No, 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 I'm still here. We are just talking about power of orchestration.
Okay. Sure. Sorry.
I'm giving some examples. No, that's fine. That's fine. No worries. All right, we should always confirm, right? So last time it happened, right? I was talking to many things and we were stuck on the first slide. So that's fine. All right. So this guy will never let my containers go down. It always only 80%. And the more and more coming, it will increase the replica because it already have the YAML file. No harm in creating extra container. So it will just go and it create it. And it does load balancing also. All right. So that way, this is basically, as I told you, right? If you heard my few keywords, right, while telling you when comparing Docker Swarm with Kubernetes, that Kubernetes is something like watching a cricket match lively, sitting in the stadium, and we are watching a live match. I know how fast the ball is running, what is his action, what is body language, and what is the body language of the batsman who's going to hit this ball, right? And once he hits the ball, how they are making the running between the wickets and they are taking the runs, right? It's not commentary. Somebody is seeing and somebody is explaining me, and then I'm imagining something. No, I'm seeing even the body language and what is the placement of the team. Each and every moment I'm capturing, I'm enjoying, I'm seeing it. lively. So Kubernetes is also like that. All right, so we'll get to know all that thing. So first of all, what is the crux of this slide? First of all, Kubernetes cannot create containers, so we need Docker. So Docker will be there to create the containers. So what happens is internally it requests Docker, hey Docker, can you please create the container? And here are my requirements. What it will tell? Image name, version name through the tag, right? So image version it will tell, and container name, port number, all the details, and Docker will create the container. Once the container is created, Kubernetes will automatically take over from there. Right, it will say thank you man, you have created, now I will manage it, and it will manage. So dependency again, Docker is our container tool, and then Kubernetes will start managing it. So this is our container management application. Okay, that is what orchestration, right? It's just a management layer to manage what containers only. All right, so this is the simple definition, right? No jargons, no diagram, nothing. Container management, and that is the power of orchestration, which you are going to learn it. All right, so moving ahead with the next slide. All right. So now I am on the second screen, which is introduction to Kubernetes. So let's understand Kubernetes. All right. So much we have discussed about it. It will do this, that, this, that. Now let's understand the Kubernetes introduction. So Kubernetes introduction is like this, right? What is Kubernetes? Kubernetes basically what happens? It is developed by Google engineers. All right. Google engineers, they developed it. And then later they donated it to the open source community, right? They donated to CNCF, which is the community who is managing this tool, Cloud Native Cloud Foundation, CNCF. All right, Cloud Native Cloud Foundation, they are managing it, right? So basically, Google engineers, when Docker came into the market, right, everybody enjoyed the life because it's within few seconds I can start the application, no coding, nothing, right? So and anybody can learn it, right? I need not to be a Java hard coder or programmer hard coder or a .NET programmer or a Python programmer, right? That hard coding is eliminated. That means anybody can understand, and we can also create our container. We can design our own images, how we want to run, right? And then we can trigger everything, right? By putting all our instruction into the build file, let Docker build the image, and then that image we can spin up the container, right? So that is how the journey is very simple. So Google started migrating their application into containers. So today Google is running billions of containers because whole world is accessing, right? So not only we people are accessing, whole world is accessing Google day in day out. All right. So Google is running millions of millions container, right? But there is no management, right? As I said, if out of million container, one container goes down, right? To fix that thing with that, where that container has gone down, right? Which one, right? Even to find out, it will take times, right? Not only few hours, but maybe weeks or maybe months, right? So there was no tool available, right? So Google came with a tool, right? So Google engineers, they sat down and feature by feature they wrote it, right? Feature by feature. Okay, we want this, we having this challenge, that challenge, this challenge, that challenge, and then they start building the tool by writing feature by feature, right? So Google engineers, they develop this tool and they name this tool as Kubernetes, right? If you just go and look at the English dictionary meaning of Kubernetes, Kubernetes is nothing but a pilot. All right, pilot. What is the job of pilot? Right, to fly the aeroplane, right? And he's also look like right us only, right? Two hands, one head, two eyes, one nose, right? One mouth, right? Two legs, two hands, right? Same like us, but he knows how to fly the aeroplane, and he take us to the destination. How? Pilot, when he sits in its chamber, right? When he sits in his cockpit, right? He is provided with a one huge dashboard, right? Where all the controllers are available, and he knows how to control it, right? And then using the front panel where all the controls are available, with that help he can fly the aeroplane, right? Because he knows, right, what each controller does, and then accordingly he will operate and he will take this flight to the destination, and we will reach to our destination. All right, and with a happy go guys, right? We will never be tensed, right? We'll be serving snacks, food, drinks, all that thing, and our journey will be a happy journey. All right, and then when we reach destination, we'll be enjoying our life just like that. We are coming with a very decent journey, and we enjoyed our journey, and we will get down to our destination, right? So we have a full faith on the pilot, and pilot knows how to fly. So who is the pilot here? Kubernetes is the pilot, and those guys, they drive our container, right? So the full lifecycle management, right, will be managed by this super guy who is Kubernetes. All right, and this guy is pilot, right, who knows how to operate because we provide all the controllers to him, and then he can operate using those controllers, right? So Kubernetes is like a pilot, all right, who will drive our aeroplane, right? Which aeroplane? Where all my containers are running. All right, so that is how Kubernetes. So it's an open source container. Basically, what is this orchestration, right? Understand this term as a, I know it's a new term, but understand as a something to manage. So if I say this is a managed thing, then how do I define this Kubernetes thing? Kubernetes is an open source container management software or a tool. So it's a container management tool. All right. So just one word. How do you define Kubernetes? Container management tool or a software. So it's a container management thing. All right. What is going to manage? Container. If I say, hey, Kubernetes, I am running some legacy application on few servers. Can you go and manage it? Kubernetes will first look at it and say, oh, these are not containers. Right? Right? These are not containers. These are some applications running on some server. Right? You say, okay, these are like my legacy application. I cannot change it. Right? Let it be run in the same old silo architecture. Right? So Kubernetes says, sorry, boss, I cannot manage it. I manage only containers. So you cannot say anything to Kubernetes. Say, hey, Kubernetes, here is the thing. And since you are the manager, management layer is with you. Why don't you go and manage it? Kubernetes says, sorry. Right? It says, sorry. Why? Because it cannot manage legacy application, anything. It manages only container management application. So it will manage only container. So the tool is nothing but a container management tool. All right, simple, right? Just container management. It has to be container, then it will manage, it will understand. Outside, it doesn't understand anything. All right, so don't say it will manage everything. No, only container thing, right? So container management software. So Google literally struggling, and they wanted to have some tool in place who can fix and who can do all these things. So they come up with this thing, and Google engineers, they literally sat down because no tool was available in the market. They literally sat down feature by feature. They wrote it, and they club all the features, and they launched this tool as a by the name Kubernetes. Right? So Kubernetes is having all the features which I will be talking right in the next few slides, just to give you more information about Kubernetes, right? Just to feel about it, just to gist about it. I'll be giving you more information down the line, right? So it was developed by Google and was released in July 2015, right? Almost 8 years, right? So 8.5 years, right? We are already at the end of the year. So officially, basically, they came in 2014, but that was alpha version, right? They throw the version alpha version, and they start taking the feedback from the market because they throw this tool to the whole open source community. So people started using, and this was a new tool. So very few people started, and there was when you launch anything, right? Then people find their in their own ways. They use in their own ways, and some people will be able to use it. Some people may not be able to use it because everybody uses in their own way. They have their own scenarios, use cases, everything. So people reported back with some issues, right? So after 1 month, they collected the feedback, they fixed it, and they relaunched by fixing all the previous issues and relaunch, which is called as a beta one, right? So beta one was basically 3 month cycle. They open the window because now people are already aware. So they open the window to 3 months. Normally beta cycle is for 3 months only, right? And they again upgraded version they throw in the market, and people again started using, and the previous issue was fixing, but new issues were pop up. So again they collected the feedback from all the people who were using, right, in the 3 month cycle, and they fixed it again, right? And they launched beta 2, right? Again they throw in the market, and that was again for 3 month cycle, right? And they again collected the feedback. So a couple of times they throw the tool in the market with the feature, and they found some issues, they fixed it, again they launched, they fixed it, like that few cycles gone, right? Alpha, beta 1, beta 2, right? And they fixed all the issues in 2014, and officially they launched this tool on July 21st, 2015. Right? No tool will be pakka, right? By throwing just first time and say my tool is working fine. No, it's not like that. We have to do a lot of testing. That is why even testing we have various stages. All right, we have various stages, right? Smoke testing, then we have unit testing, then we have rigorous testing, integration testing, system testing, UAT, right? User acceptance test, and then, right, once we satisfy all the things, then we push it to production. We never ever release just like that in production. It has to pass through all the stages, and every stage we should get a clearance. Okay, this tool is having no bug, everything is fine. Then only we will release to production. That is how this was also tested in market, and of around 2015 it was released, right? And Docker Swarm came 1 year later, right? Though Docker was released, but Docker, right, they were enjoying the legacy of Docker being so popular, right? But they realized it later that they need something else also, and Docker Swarm came 1 year later, 2016. That means this guy was already 2 years ahead. 2014 they already developed and they released it, right? So Kubernetes came little early, and still Kubernetes is a more one of the biggest and popular tool because it's very powerful, right? It's very powerful. And as I said, it is something like we are watching the cricket match by sitting in the stadium. That means everything we are going to watch it lively, right? So that is how we will see it. So when it was released in 21st 2015, right? July 21st 2015, when it was released, it became the ninth most active repository on GitHub. That means people started seeing so much development on this tool, right? Day in day out people are using, and it become ninth most active repository. Like people are doing check-in, putting their Kubernetes script, deployment script, YAML files, all that thing, and it become one of the ninth most popular tool in that time itself, right? So it is very popular nowadays. Also it is very popular, right? And if you see, this is the symbol of Kubernetes. If you see, this is nothing but a wheel, right? Normally where this wheel, if you have seen the ship, right, cruise or big huge giant ship where you find the hotels, right, big, right? And when I say hotel means have everything, right? You will see a big lounge clubs in the hotel, right? People are dancing, partying, everything, and there are, it's like a full-fledged 3-star 5-star hotel, right? So all sort of people will take cruise ride to venture across the sea, and they will go to the destination. They will feel, they want to feel it, right? So cruise has become very one of the most popular thing in the world, right? And people, right, everybody wants to experience it, right? So this is the wheel. Who will use this wheel? The pilot, right? The guy who is going to use the cruise ship and take us to the destination. And it's again happy go journey, right? We'll be partying, we'll be enjoying, we'll be dancing, we'll be drinking, we'll be doing this, that, everything is going to be a fantastic journey. But who will take us, right? The guy who is going to, the pilot who is going to drive this cruise to the destination, he'll be using this wheel. So basically this wheel is nothing but a navigation, right? This is the navigation thing where it will navigate using this wheel and drive forward, right? So this is the symbol of Kubernetes, right? We'll be using, and Kubernetes will drive our journey forward, right? So that is how Kubernetes will help us to drive our journey 24 by 7, 365 days. That's the commitment of Kubernetes. Kubernetes says, I am there to help you 24 by 7, 365 days. So we will see how it will drive our journey forward. All right. So we are going to see it. So we have seen that Kubernetes is container management, this and that, and so many things. But what makes Kubernetes so popular? Why it is making so much buzz in the market? So let's see and find some interesting features, right? So there are Kubernetes features. The list is really big, but I've collected the core features, right? Not all the features, but the few basic core features just to feel, right, what Kubernetes is going to do, right? So let's understand these features. And once you understand these features, right, same thing we will be using when we go inside the Kubernetes. Once I set up Kubernetes cluster, I'll be doing this thing, right? So all these features are available to, then it would be very easy to use it, right? When first time Netflix came, right, and how to operate it, right? There are so many movies, so many web series, so many languages, right? In Hindi, right, we have, right? In India also we have so many languages, right? Right? This language, that language, Tamil movie, Rajnikant South movie, in, right? North India movie, right? These people, those people, they develop, right? Bollywood is totally in Hindi, right? They come up with fantastic movies and all big shots, right? Shah Rukh Khan, Salman Khan, all these Akshay Kumar, big shots. South also, right? Huge guys, right? So they are our the lords of the heaven, right? So day in day out we watch these movies, right? So many things is coming up nowadays, right? OTT platform, so many movies, so many series, so many web series, everything is now playing on my fingertips, right? But how to operate it, right? So they give a small remote and just keep on whatever you want, right? Hunt it, play it, and that's it, right? So same way, these are the features. If somebody gives me the feature, it would be very easy for me to understand and drive the things forward using those features. All right, so let's understand. I have identified few features, but there are so many things. But let's understand these core features. All right, so I'll start my journey with pods. This is my first feature, pod. Pod is nothing but basically it's a container thing. All right, but what happens is people are so much crazy about these tools, right? So the whole concept has been changed by the people. So when I say container, people start correlating with Docker. So when I say Docker, people start correlating with container. So container is Docker, Docker is container. It is like that. So when I say Docker, people see, okay, I'm talking about container. When I say container, people start assuming that I'm talking about Docker. All right, so Docker is container, contains Docker. So where Kubernetes comes. So what happens? Every tool when they develop, they give their own terminologies. which is specific to their tool. That means people will understand, okay, pod means I'm talking about Kubernetes. All right, but actually what is Kubernetes? It's container only. All right, but here we are calling containers by a different name, right? Why? Because this guy, the full form of pod is production on demand service, right? Production on demand service, right? So basically everything is through micro-based services. So micro-based architecture we are using, right? And microservices architecture once you use, so everything is right just a small piece. It's a feature, right? And it will, right, likewise, like you have many features, right? So that is how everything will work as a service, right? So it's a production on demand service, but what it does, this is basically nothing but this service is responsible for containers. So whenever you want to create a container Kubernetes, this guy is responsible to talk to Docker. So this guy will go and talk to Docker by and give his requirement. Hey, why don't you pull image for Nginx version 1.21 for me? So it will request Docker with his own requirement, give it to Docker, and Docker will understand, okay, this is the requirement you want. It will start the container. So it will request Docker and get the container created, right? That is the job of this guy. Once the container is created, then this guy has to start managing it, right? Kubernetes says, okay, now the container is created, it will start managing it. Now when it will manage, it will add few more capabilities to the container. It doesn't take as the but raw container, but it will start giving some additional features. What it will do, this will go and assign an IP address to the container, right? It will give the network layer so that anybody who can connect to this container, right? So it will give IP address, CPU, memory, many resources are needed, right? And ultimately it will start monitoring. That means the monitoring layer will also be there on top of container, that this container is managed by Kubernetes, right? So that means this guy is responsible for end-to-end container thing. Whenever I say anything related to container, that means it is related to pods, right? In short, right? So container thing in Kubernetes is called as a pods, right? So when I say I'm running Nginx pod, that means I'm running Nginx container, right? So few days, right? It will take us like for us to understand, okay, container means pod, right? So few days I'll be telling, then ultimately you will also know when I say pod means it's a application container which I'm referring to, right? So it is nothing but container. So this guy is responsible for all the communication. Go request Docker, give the requirement, get the container created by Docker. Once the container created by Docker, come and start monitoring it. So everything is managed by this thing. So when I say pod means I'm talking about containers. Any action related to containers is done by this guy. So Kubernetes has appointed one dedicated person whose responsibility is to create and manage the container. So this guy is responsible for container thing, right? Which we call pod, right? Pod may be one container or maybe multiple container, right? And that is how we can manage, right? Multiple containers. So we always use plural term pods, right? Right. So that is how we always say pods. So pods means we can have one container inside the pod or maybe multiple containers also, right? So here we will understand the multiple container concept also, right? We already understood in Docker Compose and Docker Swarm, but here also we will understand, right? And I'll tell you when to use single container and multiple container, all that thing we will understand it, all right? So when I set up the cluster, first thing I'll be dealing with this gentleman. So this is also called the deployment unit. That means this guy has to bring the container inside Kubernetes. Otherwise, what will do Kubernetes? Nothing. That is the job of Kubernetes to manage the container, right? If you don't give anything to Kubernetes as a container, what Kubernetes will do? It will be sleeping whole day, whole night, right? Doing nothing. So we also call it a deployment unit. That means this guy will bring the containers inside the Kubernetes by deploying the by deploying container. That is the job of pods. All right. So this is the all container related thing this guy will do, and we will be referring pods related to container thing. All right. So that is our pod. Right. We also know replicas. All right. So Kubernetes has various controllers to control the actions, right? So they basically the controllers, they do dedicated task, right? And that is how likewise you have many controllers, right? So you have replication controller to to create and manage the replicas, right, of my application. So Kubernetes already have a controller. Controller is basically nothing but uh, to do a specific task, right? Same way we have a node controller which will basically maintaining my node. So Kubernetes has given responsibility to various things and it will manage it on its own through these controllers. Right? Replication controller, deployment controller, like node controller, token controller, who will manage the connection between my front and back end through the token encrypted string, right? Not I have to log in, I have to pass password, username, then only it will log in. No, it will automatically do it by reading the token thing, right? So if you see nowadays we are using token, which is nothing but an encrypted thing, right? So nobody can take my credential, username, password. I cannot expose it just like that, right? So many controllers are there. So Kubernetes, you will see many controllers are there, and each controller does a specific task only. So when you say, then the name identifies. So replication controller. Replication means it is responsible for replicas. All right. So when I create multiple replicas, right? So Kubernetes will have its own controller and maintains the status of replicas. 2 replicas, 3 replicas, anything related to replicas will be maintained by controller. Replicas are nothing but the same container with duplicate instances. So when I'm running Nginx, but I have multiple machines, so I'll be creating the replica, right? That means I'll clone, I'll copy, I'll duplicate. That is what the replica, exactly same to same, right? So I'll duplicate it and run the same Nginx on another node, right? So I am having the replica, right, on the another node. That means Nginx is available on this node, another node as well. If this node goes down, no problem. This replica is available on other node. My Nginx will be serving the request from the other node, right? And that is the purpose of replica, right? And as I said, we always go with a cluster based design. Remember, we cannot install all the application on one server. If anything goes wrong with this one server, my whole environment will be down, right? And we don't want to get into those kind of problems, right, which we used to face, right? So we always have a multiple machines, right? And this guy will help me to create the replicas and run my same application on other machines as well, right? So Kubernetes will assign the task to this guy, and this guy will create the replica and go back and report to Kubernetes engine that replicas are created, and Kubernetes will always maintain the inventory as a monitoring layer, as a management layer. All right. So likewise, there are many controllers, but one of the popular controllers is replication controller, right? So here we will see the replicas and all that is created, and they are controlled by Kubernetes itself, right? They are not asking me or you any question. They will not come and ask you or me. They will be controlled and managed by Kubernetes, right? So this is another one of the core feature of Kubernetes, right? Similarly, we have storage management, right? Storage management is nothing but, right, volumes in Docker we use for data store. We never ever store the data inside the container, because container will be deleted, container will be recreated, but I cannot lose my data, right? If container is deleted, my data will also be deleted, right? So we always store the data outside the container and then attach that volume to the container, so that data will be available whenever, wherever container you are, data will be available because your storage is attached to the container. Same way, here also, Kubernetes also provided its own storage, right? And it manages also. So storage management is done by Kubernetes. It will create the storage, do the attachment with your container, right? And automatically your data will be available. So we have automated whole process, right? What we have seen manually in Kubernetes, what we have seen manually in Docker, same thing it will be using, right? Same volume concept it will be using, but the names will be different. Here we say Docker volumes, here we'll be saying persistent volume. Persistent means permanent. It's not a temporary storage that as long as your container is running, we will give you the temporary storage. No, it would be permanent. All right. So persistent volume and all that thing, how to attach all that thing. So we'll create PV, PVCs, all that thing. PV means persistent volume. In short, we say PV, but the full name is persistent volume. PVC is persistent volume claim, right? My container will be claiming the storage and they'll be start using the storage, right? So that is how this guy is available. It will do all kind of management related to storage, right? No question will be asked to you or me, to anybody else in this world. No question will be asked. It will manage. It will do its job, right? Managing the storage. So it will manage the complete thing, and that is the power of one Kubernetes as one of the feature. All right, so we'll be using this feature. Now moving ahead with one more interesting feature we call resource monitoring, right? When you start your container inside the pod, right, container will be taking some CPU and memory, right? So initially when traffic is less, so for example, 2 CPU and 4 GB RAM is fine, but it can you give all the 2 CPU and 4 GB memory as a static thing all the time? No, right? My traffic may increase, right? Morning I had only one user or 5 users, but after 1 hour, 10 users, and in the afternoon there were hundreds of users who were accessing my application, right? Do you think the 2 CPU and 4 GB RAM is sufficient, right? So this guy will do a monitoring, resource monitoring, as and when traffic is increasing, right? So my compute power also, we need to provide more resources. Then only my application will be able to serve the request, otherwise it will go down, right? So this guy will dynamically allocate the resources. When I say resources, it means CPU and memory only. So whenever I say resource means CPU and memory. So this guy will monitor the resource and it will dynamically allocate the resources to my container, right? Because my container should be always up 24 by 7. And that's the commitment of Kubernetes. How 24 by 7, right? It will allocate the resources. So my application will never ever go down. It will run in its own healthy state. All right. So resource monitoring, even I can set the limits also, right? So I can define from 2 CPU, it can go up to 8 CPUs, and from 4 GB RAM, it can go up to 32 GB RAM. I can define any limits, right? So this based on all my testing, my monitoring reports and all the thing, we have been observing, okay, this guy needs more resources from last 7 days, and then we set some limit. We can change this limit also afterwards, right? Because we are constantly monitoring and we know, right, what are the peak time it goes, right? So all that depend on metrics, right? We will always set the limits, and within the limits it will be allocating the resources automatically, right? So that is the power where Kubernetes will always run these things. All right. Then health check, right? This health check, basically there are two type of health check. One health check is Kubernetes will maintain the health of its own resources, whether my pod is running, replication controller, resource controller, all resources are running healthy or not, because Kubernetes will be using its internal resources to monitor and manage my application, manage our container applications, right? So it does its own internal health check also, right, which we call service discovery, right? This is basically health service. It will be running in the background and does the discovery of all Kubernetes resources and find that, okay, everybody is healthy or not. If out of 10, 9 are healthy but one is not, one is unhealthy, this guy will come and report, right? So likewise Kubernetes does many health check, right? But what about application health check when my application is running inside the container? So Kubernetes come with few health check, right? Basically health probes are there, they are already there. So they will be checking the health of my container all the time, right? All the time there is a mechanism, right? They'll do ping, they will check the health, they will run few commands whether they are getting response or not. All actions they will do, and they'll do the health check. So I need not to worry about it, right? Kubernetes itself is doing the health check of my application, right? Kubernetes itself is doing the health check of its own resources also, right? Everything will be done by the health check. So health check is really important in Kubernetes, right? If I'm sick, right, do you expect me that I'll be working with my full capacity? No, right? Right? If I'm not well, I'll take off. That means I'm not working. My productivity is zero for that day because I'm not well. I'm sick, right? So I'm fit and fine. Then only I'll be giving my 100% efficiency, 100% productivity. Same way, health check is really important, right? So Kubernetes always maintains the health check, right? There are health probes and they will keep on go and check whether my container is still alive or not, whether it is crashed, whether it is not available, it is down, right? What happened, right? All that this guy will be monitoring the stages of my container, right? My applications which are running, and they will be seeing everything. So the health check probes are available in Kubernetes, right? So interesting feature. Networking, right? So when my pod, and likewise many pods are running, right? When one machine talks to another, another talks to them because they are connected, right? Cluster based environment. Cluster means collection of machines, right? So Kubernetes brings its own networking, right? Though I have laid down my own networking, all machines are connected well and fine. Kubernetes doesn't trust anyone, right? Kubernetes doesn't trust anyone. Though I have laid down already networking, already laid down, right? It will still not. It will deploy its own networking. Then only it will be confident. Okay, now I have my foolproof networking, right? So no trust, right? So it will deploy its own networking, and we will also be using Kubernetes networking, right? It's going to be very interesting, right? So don't think that we'll be deviating. Networking is a huge thing, but in the modern tools, right, everything is very simple. So here also we'll be understanding. Remember in Docker, right, we saw somebody's assigning IP addresses, right? When we inspect any container, right, we already saw, right, networking, subnet mask, gateway, default gateway, all that we already seen, right, because of IPAM manager, IP address manager, right? That is the part of networking who does all that thing. Same way here also, Kubernetes has its own IPAM, right? It will be managing all the networking, assigning IP address to my container. Every pod will be having IP address, all that thing, port number, everything, right? And underneath networking, because of networking, I can talk to anyone, right? One machine can talk to another. Even the container which is running on this machine can talk to the container running on the other machine, right? So we will have the communication, all that thing using networking. Networking again a interesting piece of any orchestration tool. Without the networking, it is really difficult. So we have our networking laid down. Kubernetes will lay down its own network, right? So and it will be a foolproof network, right? It will be secure network which Kubernetes will lay down, and we will be, while setting up the cluster, I'll be using Kubernetes networking, right? So I'll talk more about it. Secret management, right? Secret management, Kubernetes, right, also has its own inbuilt database. Like in Docker Swarm, we had a raft database which will be storing all the transactions, right, what it is doing, right, and keeps the record in the database, right? So Kubernetes also come with its own database, inbuilt database. I need not to create anything. Right, when you set up the Kubernetes, right, this is an inbuilt database of Kubernetes. It will store all username, password, database connection, string name, port number, IP address into this database. So that means Kubernetes is not going to put anything on flat files. Why? Flat files are prone to be attacked. Right? Flat files are prone to be attacked. That means anybody can open my flat files and they can retrieve the information. They can steal the information. My username, what my username I'm using, what my password is. Right? They can steal the information from flat files. So Kubernetes never ever keep anything on flat files. It will be everything in an inbuilt database, and this database is very powerful. It's an encrypted database. Everything will be right. Right? If anybody wants to take anything, it would be junk characters because it is encrypted. All right. So we have an inbuilt encrypted database and we put all our secret. When I say secret means all confidential data, right? Whether it's my username, password, IP address, database connection string, database name, anything, right? We will be keeping inside the Kubernetes only, which is our Kubernetes inbuilt database. So secret management, I will be creating secret management using encryption, decryption, all the algorithm which Kubernetes comes with as an inbuilt, right? Encryption, decryption, again, inbuilt tool Kubernetes uses. I'll be doing all that thing and I'll be teaching you, right, how to create your username and password, right, as an encrypted thing, right? So I'll be teaching you all that thing and then we'll be loading into this database, right? So we will be seeing all that thing also, right? So it's going to be very, very interesting. Kubernetes, right? Security is very, very high in Kubernetes. And that's the reason we are using all secured feature of Kubernetes, right? So where my information, right, related to my application, username, password, database, or anything will be secured. Rolling updates, right? So as and when I want to upgrade my application, right, so I can just go and roll out the updates, right, without bringing my environment down, right? So absolutely with zero downtime I can upgrade all my applications, right? So that means when I'm running container, let's say nginx 1.20, right, but my development team already come up with a new version 1.30 or 1.40 or 1.50, right, or maybe 2.0, right? So no need to bring the environment down. So Google engineers, when they will literally doing all these things feature by feature, they were writing about this tool, right? This was all the thought process on table, and they thought that okay, every time whenever we want to upgrade our application, right, when they are running in a container, right, we should not bring our environment down. It should be available 24 by 7, 365 days. So that means they have to consider that scenario also. And this is the feature. Using this feature I can do all upgrades, right? I can do rollback or upgrades, anything I can do on the fly, on the go, without bringing down. In Docker Swarm also we have seen this feature, right? I upgraded, right? And then we roll back also. Same way here also, but here it is more ease, right? With, as I said, it's a lively match we are watching. So everything will be transparent and we will be using these strategies, upgrade strategies and all that strategies. And I'll be using those things to upgrade application, right? Using the inbuilt feature of Kubernetes. So we'll be doing all the thing, right? So we call rolling update strategies. All the strategy we'll be using it and we'll be updating it. All right, so no downtime, absolutely zero downtime. Then last but not least, this feature we have service discovery. So Kubernetes comes with an inbuilt service discovery. Basically, it's a service running in Kubernetes all the time, 24 by 7. Right? It's basically cluster level service which is running across Kubernetes. What the service does? This service every 20 minutes goes and it takes the discovery. Discovery means it will take the current state. It will take the stock and inventory of the current state, that this guy is running fine, 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 networking fine, secret database is fine. My database has to be always healthy, right? And the rolling update feature is fine. Then it will take the store that okay, in right Kubernetes engine, when I say Kubernetes engine should be healthy, then only it will be able to do my task. Then it will be able to manage my content. Then only it will be able to monitor my application, right? So it will do the discovery that my Kubernetes, all the Kubernetes features are healthy or not, right? So this guy will take the inventory every 20 minutes, right? It's like a cron job, schedule job kind of thing. It will just go trigger and then take the inventory and update the Kubernetes engine that okay, all our resources are healthy, no problem, right? The Kubernetes, right, always see, right, the project manager, what he does in the morning. First of all, he just look at the team, whether my full team is available or not. If somebody is not available, what are the priorities? Are we going to miss anything? So he has to do some planning here and there. So same way, Kubernetes also does planning that whether all our resources are healthy or not. If not healthy, this guy will automatically go and trigger, right, that what is unhealthy, it will try to make it healthy, right? So many capabilities have been added in Kubernetes, right? And that is the power that we need not to worry about anything. Everything will be self-managed. Everything will be managed by itself. We need not to worry about it. Right? So we have health checks, we have service discovery, many things are there, which will take the health of Kubernetes, right? And it will check the features which we are going to use in Kubernetes. Everything should be healthy all the time. And that is the job of this service, right? It's going to be very, very interesting. All right. So these are the few features, and we will be, once I set up the cluster, we'll be seeing all the things lively, and I can revisit you and we can come back to this slide and do verification and validation. Okay, this feature is available. This will be do this and that. Anyway, there are sessions, right? Storage I cannot do in just in 10 minutes. So we have one full session, maybe multiple sessions. Pod also will be dealing with every day, right? Secret management, rolling update, all that will be doing it. And these guys will be helping in the background. Resource monitoring, health check, service discovery, always be there. And they'll be doing in the background. We will also be come to know, right, about this thing. I'll show you where the service discovery is and what it does, how it does, all that we will be able to see it lively. All right. Let's move on. I know theoretical part today, right? So theoretical part slightly boring, but that's fine. We are just building our interest of areas, what Kubernetes is going to offer, we are trying to understand that part. All right, now let's understand the architecture, right? And hear me guys, if you understand this architecture, life will be very easy, right? So just hear me out. I'll revisit this slide multiple times again and again. Initially, for the first right few days, I'll be revisiting this slide and I'll be telling you every day looking at the slide so that you should not forget it, right? So let me start telling. So what I've done is I've divided this slide into two pieces, right? One is plain vanilla diagram on my left hand side, and then we onboard what are the master node component, what are the worker node component, and then we onboard the component and we'll do a detailed study of Kubernetes architecture. All right. So first understand the plain vanilla diagram so that you can understand what Kubernetes is, right? What Kubernetes is all about. Let's understand, right? So stay tuned on the left hand side, then we will move from left hand side to right hand side eventually. All right. So as I said, this is master and slave, right? But nowadays we cannot say slave to anyone, right? It's very, very inappropriate word, not even to machine. So what we say master and worker node. What is the job of master node, right? Master node is managing all my worker nodes. What is my worker node? Where my applications will be running. So where my pods will be running, where my containers will be running. So if you see worker nodes, what is running? All our containers are running as a pod. All right. But master node is just a management layer. No containers will be running here, right? No means no, absolutely no. It will just manage the worker nodes. All right. So master node will be assigning tasks to each worker node, and all worker node is reporting to whom? My master node. It is something like master node is our project manager. All right, like project manager, and it is managing the team. So many developers are there, right? Maybe developers, testers, and maybe right, all mix of people who's managing. Project manager is managing. All right. So worker nodes, they are never interconnected. Right. In Docker also we have seen, right? Right. Manager node and worker node we have seen. But here we don't say manager, we say master. Right. Master is nothing but the main guy. Right. Who is main guy? Project manager. Right. So same thing. Master node is the main guy who will be managing all the worker node. If anything goes wrong to this worker node, who is responsible? Master node. And if you see, if master node wants to talk to this guy, he can talk to this guy. If master node wants to talk to this guy, he can talk to this guy. If master node wants to talk to the third worker node, he can talk to this guy, right? So he can just go and talk to this guy. He can go and talk to this guy. He can go and talk to this guy, right? So that is how master node is connected, and everybody is reporting to whom? Master node. So that means communication between master and worker node will be done by master node. All right. So this guy will be managing the worker node. That is the job, right? Not the pod, right? Not your container. Container will be managed by worker node. Each individual worker node will be managing your containers, but who's managing this worker node? Master node, right? Now, how many master, how many worker nodes can be managed by single master node? Up to 5,000 nodes, right? So it's a big elephant. 5,000 nodes. Are you crazy? Yes, I'm crazy, right? So one cluster can manage 5,000 worker nodes. Imagine the power of Kubernetes, right? So Google is running few parallel clusters every day, right? And each cluster is having around 5,000 nodes, right? So that is the power of this master node. All right. So for high availability, as I said, only one project manager should manage the team. Multiple project managers will always lead to confusion. Nobody will understand what multiple managers saying. Morning manager, evening manager, afternoon manager. Remember, I told you the story in Docker. Same thing here also. Only one master node should be active. We can have passive master nodes also. For high availability, I can have, but they will be not active. They will be passive. But only one at a time will be managing it. Right? That's why you will see one master node is managing all my worker nodes. All right. So this is how this guy will be managing. So I'll go to right hand side and see what are the components this guy needs and how it is managing it. Right. So let's go to right hand side and see. So if you see here, there are 4 boxes. Right. Only 4. Remember these 4 boxes, or at least remember the number. Right. So there are 4 boxes. Right. So these are square bracket and these are something like rectangle or a horizontal box, right? So we have given some name to this box, right? First box, right? I've given the name as etcd. Etcd is the database, inbuilt database of Kubernetes, right? As I told you, it will store all the information. How many worker nodes are there? What is the IP address of this worker node? So this guy will be having. What is the IP address of this worker node? This guy will be having. So this is the database having all the details of the cluster, right? And all details of cluster is stored where? Only inside this database, nowhere outside database, right? No flat files or nothing. Everything is stored in this database. So this database is keeping record for worker 1, keeping record for worker 2, keeping record for worker 2, like that, like that, like that. Many records are created and all the details are stored inside this database, right? It will create one, right? One full record table for worker 1, then second for worker 2. Like that, many records are created and all details are available in this database. And it's the inbuilt database of Kubernetes we call etcd. All right. So I'll be talking about this guy and we will also be talking about this guy. Right. And this database is highly secure database. Nobody can access. Can you query and get the information, or can I go and query and take out the information? Right. No. Right. Not allowed. So no access is given to you and me. Only Kubernetes internal engine will be having the access. And who is the internal engine? The second box, API server. This is the server component, or I would say basically Kubernetes engine. This is our main pilot, right? Kubernetes is what? Kubernetes is nothing but pilot, right? Who's our pilot? This is our main pilot. This guy will fly the aeroplane. That means all the day-to-day operation, all the action will be done by this guy, right? And this all other guy, etcd, scheduler, control manager are the helping component, right? Or I would say the sub component of API server. The main guy is API server. So API server is the pilot, and these are the controllers in the front panel, right? For the pilot, how he will fly the aeroplane, right? He is provided with the huge dashboard and all the controllers are there, and he has the navigation screen, all the controllers, right? Right? How to fly the aeroplane on the runway, how to take off, and then how to fly the aeroplane in the air, and how to see where is my destination, right? All controls are on dashboard, right? So same way, this is our main pilot, and these are the controllers on his dashboard, right? etcd, schedule, controller, manager. The 3 components are sub-components, or these are the helping components of this main guy we call API server. API server is the main guy. And why we call API server? Because Kubernetes will be accessed by API. API means some URL. I can access it over the browser also, right? So this application will be accessed by API, right? So nowadays all services, right? So we access through API, right? By default REST API. I gave you the example of Google search engine, right? Wherever search engine, I can use my URL and I can reach to Google engine, www.google.com, right? What I'm looking, just put the keywords and Google engine will give me all the details, right? And my job is done. Same way, this is our main pilot who will be using all the things. Whenever he wants to see what is the detail of worker node, what is the IP address, he will just go and check in the database and he will get all the details of worker 1. When you want to check the detail of worker 2, this guy, right, I'll go and check the details in etcd. When I want to worker 3, like that, like that, like that, all details I'll be pulling from this database, right? So, and it's an inbuilt database. And who will have? Only this guy will have access, right? Even you, me, we are admins, right? But no access, right? How? We will see the power of Kubernetes security feature, how this data is being accessed, right? So we'll see all that part, right? And we actually we don't need it also, right? Let this guy do, because he is the pilot. He will be doing all the tasks, right? So let him have the access to this data. Only this guy will be having access, nobody else. All right. So this guy will update. Let's say if I want to add 4th worker node, this guy will go and update the record here, and then he will be fetching the record as and when he needs it, right? As and when he needs it, he'll be doing. So this guy will be accessed by this guy, not by you, me. We absolutely have no access. So it is so much secure. All right, this is our main pilot, right? So whenever I first, right, let's say my cluster is ready, and now I want to start with my first container I want to deploy, right? I want to start my container in Kubernetes. So how will I do? This is a scheduler, right? Scheduler will help me to schedule my container. So this guy will help me to schedule the container, right? Now, what is the job of scheduler, right? The scheduler, it will schedule my container in Kubernetes, but how, right? So what this guy does, right? Scheduler basically maintains the inventory of all my nodes. That is the only job of scheduler. What is the job of scheduler? This guy will just maintain the inventory of worker nodes. How many worker nodes you see in my picture? 3 worker nodes, right? Here also you see 1, 2, and 3. So scheduler will maintain the inventory of worker nodes, right? And when this API server wants to deploy my container, it will check the status with scheduler. Hey, scheduler, I want to start this container, right? Container means pod, all right? So in Kubernetes, I will always say pod. I want to start this pod. Where should it go, right? So this guy maintaining the inventory, it will say, okay, last time we already deployed some container on worker one. So worker two and worker three, we haven't deployed anything. They are doing nothing. They are sleeping, right? But this guy is busy with running some container because last time we started few containers here. So this guy maintains the inventory. Will say, okay, one is already busy because last time we scheduled some containers and some pods are running. Pods means container are running. So this guy say, okay, worker two and worker three are available. So my next container will go where? This guy will tell me. This guy will tell me that okay, it should go to worker two or worker three. One of the node it will assign. So scheduler will assign the node. Node means worker node, and then my container will be assigned to that node, and it will start the container. All right. So the scheduler will do that job. Right. So scheduler maintains all the worker nodes and plus maintains the metrics also, right? So last time when it deployed, it will see, okay, worker one is already at 40% or 50%, right? That means some work is assigned to worker one, but nothing is assigned to worker two and worker three. So it will next container, it will do the placement on worker two or worker three. Let's say worker two, I've deployed this container. After 1 hour, I want to deploy another container. So this guy, when it wants to deploy, when it wants to start the container, where it will start, first of all container will be on worker node. Nothing will be on master node. So it will go and check the right scheduler. Hey, scheduler, I want to schedule the third container. Where it should go? It will tell, okay, it should go to the worker three because last time we already assigned some work to worker one and worker two as well, but nothing is assigned to worker three. So this guy will tell me. So it maintains the inventory of worker nodes and maintains the metrics also. What is the current utilization on worker one? What is the current utilization on worker two? What is the utilization of worker three? Right? If I develop all three containers, then it will maintain the metrics. If I want to deploy fourth container, it will tell me, okay, worker one, right? Long back we deployed, so only 40% workload only there on this guy, right? So CPU memory is only 40%, it reaches to 40% only, and worker two 60%, worker three 80%. So logically where it should go, right? The guy who is having less traffic, right? The guy who is available. So only 40%, that means 60% available. So it will go here. So like that, it maintains the inventory and the live current status of what is going on in worker nodes, right? What is going on each worker node, who will maintain the inventory, scheduler will maintain the inventory, and this guy will just maintain, it will just go and check with this guy. It will not go and come here, hey, knock, knock, open the door and tell me what you are doing. Oh, you are running this container. Can you take one more request? And no discussion, right? This guy will say, oh, why should I take more request? Oh, no, 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 I'm busy. Then knock, knock, open the door. Hey, can you take my container? No, 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 I'm busy. Like nobody will listen to this guy. All right. So this guy will check here and then they will deploy. It will not go to any worker. It will directly check it here. And who is taking the up-to-date status report? Right. Scheduler will always come up with up-to-date report. What is the report? Inventory of my worker. All right. So this guy, as I said, all three components are helping components. This guy will take the help of this guy, right, or this guy, right, and then one more component we have controller manager. So what happens is Kubernetes has hired one manager, right? Hired one manager. Why we need manager? Because there are so many controllers, right? As you see in my last slide, I was talking about the replication controller, right? This controller, replication controller, like we have node controller, right? We have token controller, replication controller, deployment controller, job controller, many controllers are there, right? As I say, what is the job of controller? They do specific task only. So when I want to create replica, only this controller will go and create replicas, not all the controller. When I want to take my username password to connect with database, or my front end wants to connect to database, how? Through the token controller. Token means it will store my encrypted username password in a token, and then it will pass to my Docker engine so that Kubernetes engine so that my front end can connect to backend. It will read the information from that token, right? So token control, node control, anything goes wrong to the node, right? Health check and all that. Who will do the controller related to node? So like with many controllers are there. So Kubernetes cannot go and talk to each controller. Hey controller, how busy are you today? Can you take new tasks, right? And that guy will deny, right? Somebody also he wants to deny, right? Kubernetes cannot get into all that thing, right? So it will just go and talk to the manager, right? Imagine, right? Let's say the CTO wants to take the status of all the projects, right? Who is the right person to give the real status of the project? Project manager, because he is having the full information, right? He knows about how many developers, who is doing what priority, when we are going to deliver, who is going to deliver what, all the priority he has set and he knows. Plus, he is having meetings with client also, right? And he's updating the client and client is also updated. If client has to say something, he will say to project manager and project manager will pass the message to the internal team, right? Maybe the strategy, maybe some change or maybe some upcoming milestone or maybe something new, right? All discussion will be routed both inside and outside will be project manager. So the CTO cannot come and ask each and every developer, hey developer, can you tell me, right, whether we are on track or not, right? What you are doing? Developer will always confuse him because developer knows only his thing. He say, I'm developing this feature, but I'm dependent on, right, somebody else, right? I'm dependent on the front end people or back end database people until unless those guys be done with those the database development, and then I will test my thing. I will test my feature whether it's working or not, but they are not yet ready. So I'm waiting for them, right? The CTO will be fully confused. Then he'll go to database guy. Database guy say, yeah, we are building it, but it will need another 7 days. But we are not sure. It may go to second week also because we haven't tested it. So once we test, then there might be some hiccups, there might be some few challenges. Then we'll be fixing those open challenges, all that thing, right? So CTO will be now damn confused, right? So he should not go and check the status and collect this from the each and every developer. He should talk to project manager. Same way, Kubernetes also will never ever go and check each and every controller what you are doing, how much time you need, when you will take next day. It will not like that. So it has hired one manager. Let the manager manage all the controllers. So the controller manager is managing all the controllers, right? What is the controller? The specific task, right? So each controller is doing a specific task. So we have many tasks, but each controller will be doing a specific task, so no confusion. Whenever I want to create replicas, I'll go to replication controller. When I want to pass my username password, I'll go to the token controller. When I want to deal anything with related to my nodes, worker nodes, I'll go to the node controller. Right? Whenever I want to deploy a new thing, I'll go to the deployment controller. So each controller is doing a specific task, and who is managing these controller, all these controllers? Right? This guy, controller manager. So Kubernetes had one manager, and let this manager go and assign the task and get the task done. Come back and update the status to API server. So API server is taking help, right, from the etcd because all configuration details of cluster is stored inside this database. API server is taking care of the scheduler as and when I want to deploy any container. I'll take the help of the schedule. Schedule will tell me which worker node is available or not available. It will give me the correct status, and accordingly my containers will be deployed on maybe worker 1, worker A, worker B, worker C, right? Right, like that, like that. It will help me to schedule my application. So that is why we call scheduler, and all these are inbuilt. I won't be creating anything. Controller manager, who would be managing my controller, right? So there is a basically service who will be taking the inventory reports and maintain its own metrics and give the status to API server. So that is how whenever I need any information, this guy will be dealing with it. But who is main pilot? API server is our main pilot, right? API server is our main pilot. I'll take 5 more minutes and then we will stop here, right? I will not take more time, right? Worker node, if you see only less component, right? Kubelet and kube proxy are the only two components which are available. But on master node, how many components? 4, right? 4, and you should remember the names of the 4. Normally in interview, people will, right? People might ask you that what is different between master node and worker node. So you say master node has 4 components and then give one line description, right? etcd is inbuilt database where all configuration will be stored inside the database. It will keep record for each and every worker node, right? All the information is here. What is the IP address of worker node 1, worker node 2, worker node 3? Everything you will find it in etc. So API server will be using that database. API server main pilot, main guy who will be doing all day-to-day tasks, right? And these are the sub-components who will be helping him, right? As and when it wants to schedule or start a pod, it will talk to schedule. Schedule will be trying to schedule my pod on available worker node, right? One of the available worker node. Controller manager, any specific task this guy wants to do, it will talk to control manager. Control manager, right? There is a huge list of controllers, right? Based on the task, what kind of task I want to create replica, it will go to replication controller. I want to check the health of my worker node, it will go to the node controller. Or I want to attach a new node, or I want to delete a node, or I want to upgrade the node, anything related to node, right? It will talk to the node controller. Like that, many controllers are there, and we have a controller manager who will managing this controller, right? So API server will just talk to control manager, and the task will be done by control manager will give the task to appropriate controller and get the task done and update the status back to API server, right? So only 4 components. Worker nodes only 2 components, right? Anyhow, pods will be running, right? So that is, we already know that pods where it runs always on worker node. So basically pods will be running, but what are the components? Kubelet and kube proxy are the 2 core components of worker nodes, and these are local components. Every worker node should have this component, right? These components are local, means they know only about this worker node only. This kubelet kube proxy is of worker node 2 only. So these guys work for only worker node 2 because they are available only on this node, right? They are not global component. They don't know. This kubelet doesn't know what is kubelet 1 worker node 1 is doing, what kubelet worker node 3 is doing. They don't know, right? Because they are local to that node only. So every worker node have to have this local component called kubelet and kube proxy. Now let me give you the information what is kubelet and what is kube proxy, right? So what happened? The master node has deployed one agent, right? So kubelet is the agent of master node. So let's say, what is the help of this agent? So let's say master node wants to talk to worker one. How it will talk? Right, through the kubelet. It will say, hey kubelet, right? So that means I am headquarters in Mumbai, right, or maybe Bangalore, right? And we have sub offices, right, at various locations. We have office in Pune, Chennai also we have office, Hyderabad also we have office, right? Delhi also we have office, right? Like many cities we have office, right? So how we can talk? I just open the directory and I'll call the Pune office, right? And Pune office, right? This guy will be reporting and I'll take the status. I want to talk to some Chennai office, I'll talk here. I want to take stats from Hyderabad, I'll talk, because we have, right, our office and everything is all connected. So this is basically an agent, right? So what master node does, master node will deploy one agent on the worker node, and this agent, right, as and when I want to talk to this worker node, so master node wants to talk to this agent node, it will talk to this kubelet and take kubelet is responsible to provide all the status, right, the live status of this worker node. It will provide the status to the master node. So that is how master node whenever wants to talk to worker node 2, I'll talk to kubelet and kubelet will provide me status, what is going on here, provide me status, and that is how, right, I will be always talking to worker node 2. That, let's say want to talk to worker node 3, I'll talk to this agent, and this agent will tell me what's going on this node, and I'll get the updates from this node. So kubelet will always send updates to whom? To master node. Master means which component? API server, right? This is our main pilot. So API server, whenever it wants to take any status or anything or any activity it wants to do with on particular worker node, it will talk to its own agent and take the status or give assign new task, and that will be given to kubelet, and kubelet will perform the task, right? Let's say I want to start the container, right? So I'll tell, hey, I want to start 2 pods, right? So I'll just go and start the pod, and as I said, pod may be running one container or multiple container, right? So pod will be running one container or maybe multiple container. That is depends on our use case, and we'll be discussing those use cases tomorrow. Very simple, don't worry about it, right? It's all about dependencies and all that thing. All right, so this is the thing, right? When my containers are running here, proxy will act as a firewall, right? It acts as a firewall. I cannot open the gate and, hey, come, I'm running here, why don't you access me, why don't you? It's not like that. I cannot open the gate for all the world, right? Whole world will then do attack, and then they will steal the information, right? So what we do, we put a firewall here, right? So firewall means my request will come to kube proxy, it will validate here. If my request is appropriate, I want to access this pod on port 80, right? You'll see, okay, port 80 is open for this, then only my request will be served. So this guy will be doing the filtering job. It will filter the traffic. When traffic will come, it will validate. If the request is inappropriate, it will reject it. If the request is valid, it will allow to access, right? So if somebody wants to access my Nginx pod, which is running here, right? But Nginx we have started on port 80, but somebody is trying to access on port 5000. Will he get the response? No. Page not found because that port is not open, right? So firewall, we have deployed the firewall. Firewall is nothing but a gate, right? Nobody can just come straight and take all the details or access my application just like that. There is a firewall. Through the firewall, the request will be passed, right? So we put a gate. All right, this is the firewall. So that is the job of kubelet. Kubelet is an agent of master node. Whenever master node wants to talk to this worker or this worker or this worker, right, or any worker, right, so he will talk to his own agent and take the status. So kubelet is nothing but the agent of master node. So one agent is deployed. Now the communication is really easy, right? When master wants to talk to this guy, he'll talk to this agent and he'll get the details. Whenever I want to talk to this guy, I'll talk to my agent on worker node 2, I'll get the details. Whenever I want to talk to worker node 3, I have my agent and I'll talk to this. All right. So once I set up the cluster, I'll tell you what are the master node components. When I go to worker node, I'll tell you what are the worker node components. So we will get to see all these components lively when I set up the cluster, right? So tomorrow we'll be setting up the cluster. All right. So this is the thing. Now focus it here, right? Focus it here, and that is what is all my 4 slides. So here it is a bit colorful, but here all black and white, right? So master node, remember 4 core components, and those 4 components are available here, right? etcd, API server, schedule, and control manager, right? All 4 components. Worker node, which what are the 2 components? Kubelet and kubeproxy, right? So master node and the worker nodes we have horizontally we have placed it, right? So basically it is basically the main entrance gate, right? When you go to office, let's say we have 3 towers in office. So these are our main entrance gate. Everybody has to enter here, whether I'm coming through a car or a bike or a walking or maybe Ola, Uber, right? I'll be coming through this main entrance gate, right? Let's say we 3 are friends, right? So let's say like you are sitting here, I'm sitting in tower B, and our dear friend also sits in tower C. So we have tower A, tower B, tower C, right? But you sit in tower A, I sit in tower B, our dear friend sits in tower C, right? We cannot come and enter from back door entry and go to tower A directly, or I can go to tower B directly, or our dear friend will go to tower B directly. No, right? We have to come here, right? Always from this is our entrance, right? So we have to come here, and there is a security guard who will do validation and verifying that I am the authorized user of this, or I'm the employee of this company or not, right? They will do, right? They will ask for my card. I have to exhibit my card, then fingerprinting, beep sound will come, then it will open the gate and security say, okay, this is guy, our authorized person. They will let me in. Once I in, right, I can park my car here or my bike or where my Ola, Uber or where they will drop me here. Then I can walk down to tower A. Maybe I am sitting in tower B, I'll go to tower B, or maybe in tower C, I'll go to tower C. But entrance is always one only. I cannot do back entry to tower A or tower B, tower C. No. So that means in Kubernetes, you can enter through master node only. Master node will do all validation, verification, and authentication, right? And if you are authorized, then only it will let you in. So in Kubernetes also, we will enter through the main gate only. We cannot do backdoor entry. So that means we cannot access the worker node directly. We have to be here on the master node. Right? So in Kubernetes, the entry is through master node only. Remember that, right? Never ever just go and jump to worker node directly. No, not allowed, right? So always master node. So how we can enter in Kubernetes, right? So I'll rotate this diagram to 90 degrees, right? So now instead of putting my worker nodes horizontally, I will put vertically, right? I'll rotate this diagram to 90 degrees so that we can understand the logic. So here, same diagram, I have rotated it, right? So instead of this horizontal, I am putting vertical, right? 90 degrees. So this is my worker 1, kubelet and kubeproxy are here. Worker 2, kubelet and kubeproxy, kubelet 3, worker node, right? Worker node 3, kubelet and kubeproxy, 2 components. And my master node, how many components? etcd database is here, scheduler is here, API server main guy here, and controller manager is here, right? We say controller, this is our control manager. This is master node, 4 components. So you and me, as I said, entry gate is only the front end gate. We cannot go to tower A, tower B, tower C directly. Entry gate. How we do enter? There are many ways. I can enter through command line interface. Kubernetes has its own CLI, which is command line interface. So we can do through command line, and we can get into Kubernetes cluster, or APIs through the URL, right? APIs. Nowadays even dashboards also, right? Normally all tools they are giving dashboard, monitoring tool, right? Everything they are giving dashboard. Kubernetes also have dashboard. We can directly log into dashboard and see our master node, worker node, pod, everything on the dashboard, right? It will display indicator. All pods are running fine, means green. No need to check the log files. Everything is green. If somebody is sending yellow, that means somebody is sending warning. Yellow means warning. Somebody is sending warning. We have to just go where the yellow indicator and click there and get the details. What this warning is all about. Get the details and try to fix it, right? Some is showing a red indicator means something has really gone down and immediate attention is needed, right? So dashboard is basically nowadays very easy thing, and nowadays everybody gives dashboard, right? Even if you are doing network side or infrastructure side, right, they are also using dashboard where they see all our nodes and right, like virtual machines and all that they can see. So dashboard and the monitoring and everything comes with a dashboard with indicators, so it would be very easy. So there are three ways we can, but as I said, entry gate is always master, right? If my friend also wants to come and wants to meet me and I've asked him to come to my office, he will also come through master node. He cannot directly come, hey, you sit in tower A, I'll jump the wall and come and meet you here. No, not allowed, right? So this is the entry gate, right? And there security guard, they will do validation verification. So that means my authentication will happen here, right? As I said, we don't have direct access to etcd database, right? So only API server is our front end, right? API server can talk to etcd, but I cannot talk to etcd directly. As I said, database, no access given to me, you or anyone, nobody can access, right? Only API server can access. He can write or read the information from this database, right? For high availability, you can have, you can copy this database and create replicas also, because this is our critical guy. All information stored in this database, it should be always up and running. If this database goes down, right, because it's also a component, right? Anything can be corrupt anytime, right? So for high availability, you can have your key store database, right? And you can keep it outside. This guy will send packet to this guy and this will be updated. This will also send packet to this guy. So you have multiple etcd instances running as a high availability, as a passive, right? Only it will send packet to here and this guy will be updated. It will send every 5 minutes, it will send packet here and this guy will be updated. So like that, this will be synchronized and they will be updated. If something goes wrong, then we can use one of the database where we have backed up, right? Passive database, and we will take the details from that database. Maybe this or maybe this will take, but at a time only one database will be here. So these are primary database, and secondary if you want to create for high availability, that if anything goes wrong, your environment should not be unavailable, your environment should be available. So we can keep the replica of the database as a backup or a standby, and we can use it later, right? So etc database is like this. Scheduler, API server will take the details, and whenever I want to schedule anything, I'll talk to scheduler. Controller manager also, API server will talk to control. So they are all reporting to whom? API server, and that is how the API server will be. These are helping components. They'll be helping API server. From API server, I can go to this worker node, or I can go to this worker node, or this worker node, because the worker nodes are connected to master node only. They are not interconnected. I cannot go here and then from here to here, or from here I want to go to worker node 3. No, right? I can go to this node or this node or this node. Same way, when I want to deploy applications, schedule will tell me, okay, worker 1 or worker 2 is available, and accordingly I'll be pushing my pod. So worker 2, then it will, my pod will come. If worker node 3, my pod will go here. So for us, entry point is master node. And normally master node is our controlling unit. Everything we will see it here. Right? This is our main guy. He'll be updating the status. So no need to, we cannot go and control worker 1, worker 2, worker 3. Who will be controlling? API server will be controlling them. Right? He is managing. He has all its components. Scheduler, who is giving the real inventory, right? What's going on, and right, who is available, who is not available. Real inventory is given by scheduler, and API server will be keeping track with the help of scheduler, keeping track of all my worker nodes. We need not to go and manage this guy. Hey, why you are running pod? I don't like it. Delete it. Why don't you start my favorite pod? Then it will take request. He say, boss, who are you? I don't know you. He knows only one guy, and that is API server only. All right. So remember, so for you and me, we will always be at master node only. Right? We cannot go to all the 5,000 nodes and take one by one inventory. Oh, what you are doing? Okay, worker 1, you are doing the, oh, what worker node, what you are doing? Oh, worker node 3, what you are doing? Like never. Right? We always be here, and this is our front end. Right? That is why I have told you that we'll be always here. That is why we have created this slide. So master node is responsible for all managing Kubernetes cluster. Who is responsible? This guy. It is managing all my worker nodes, my pod, everything is managing, and these are the component, 4 components where through which he will be managing. Right? It is the entry point for all administrative tasks. Even, right, if I want worker node 1, right, I want to attach a disk or I want to upgrade an operating system, all admission tasks will be done by master node only. Right? We have to inform this guy. I cannot directly go and shut down my worker node 2 or restart my worker node 2. No, my application is running. If I just restart just like that, blindfolded, right, that means my application will be killed. Right? So we cannot do that. So even for administrative tasks, we'll be doing through master node only, and I'll be doing all administrative tasks from master node. How, that I'll be telling you. All right. So even for anything, right, we'll be doing through master node only. Can be more than one master node? Yes, I can have multiple master node also, because this guy can go down, right? This guy can also be corrupted. right? So we can have multiple master node, right? Remember my Docker Swarm design, right? Manager 1, always leader. Manager 2, manager 3 will be reachable, right? In the event of failure, we can reach to them, right? Same way here, active manager will always be only one, but we can reach to other master node also, right? So same design will work over here also. Only one of them will be leader, right? And that is true, right? We don't need too many project manager. Only one project manager is fine to manage the team, right? So same way here also, one guy will be actively managing my or leading my cluster, right? And that guy is leader. The leader who is going to lead my cluster, right? The active master node only. Kubernetes uses etcd, right? Though we will not have direct access, but don't forget this guy, right? This guy, we won't be dealing with this database directly, but though it's a silent component, but it's very, very important component. All right, remember that. So we will revisit to all these things. Don't worry about it. I've created just few slides to just give you the first impression of Kubernetes, and we are trying to understand. And tomorrow we'll do the installation.